Hey, what's up, everybody? This is the Helpful Hacker, and today we are going over the Shells Overview Room from TryHackMe. So we'll jump right in and get started with task number 1, the room introduction. So this room, again, Shells Overview, we're going to be talking about shells. We're going to learn kind of what they are, why they're important, and how we use them in the world of cybersecurity, right? So you kind of need to know it for both offensive and defensive. But this is TryHackMe, so they're going to mostly focus on it from an offensive kind of lens. So if you go through here, it'll give you a quick overview, learning objectives, and some room prerequisites. So the truth is this room can seem pretty intimidating, especially I would say if you learn it to like a really high quality, right? Because you can get through this room and just kind of get a really basic understanding of what shells are, or you can go through the room and really understand every single payload that they give you. And that's what I would recommend. I mean, it's there, it's available to you. You might as well take full advantage. So that's what we'll do. So it might seem like a lot, but it's really not that bad once you get the hang of it. And then some caveats. They're not going to encourage the use of like Metasploit or any other frameworks that will automatically generate payloads or shells for us or listeners, because that's not the point. The point of the room is to really understand shells and what they are. And the best way to understand them is to see how they actually work, not just get a shell.php file generated for you. So start the machine, make sure you've read everything, mark complete. And with that, you're done with task number 1. Now it's on to task number 2. This task is going to go over what a shell is. So right here, they give a really good definition. A shell is software that allows a user to interact with an operating system. It can be a graphical interface, but when we refer to it in cybersecurity, 99% of the time we're talking about a command line interface. So what does this mean? When you're normally browsing your computer and clicking through, the graphical user interface, you click on the start button, you go into search, you click on your Internet Explorer or your Safari or Google Chrome or whatever you're using. As you click on that stuff and open it and interact with your computer using your mouse and keyboard, that's a graphical user interface, right? You can see it. You can click on it. You can go into your documents and you can see the whole file system. That's graphical. Now we're talking about command line, which hopefully at this point you've used a command line before, and that's just another way to interact with the operating system. But the point is it's a software that lets you interact directly with that operating system. And again, most of the time in cybersecurity, we're talking about that command line interface, and we'll often refer to it as a shell. And more often than not, we're referring to, when we say shell, it's usually malicious. We're usually talking about something bad. If someone were to come up to you and say, hey, I found a shell on, our web server, that's bad news. Okay. So that's usually how we refer to it in cybersecurity. And then down here, it talks a little bit about what you can do with a shell. And you can read through all these. They're just definitions. Some of them you should know. I think one of them's in the questions, so make sure you go through and do that. But to keep it plain and simple, what we're really talking about here is with a shell, it's no different than the hacker sitting in front of your computer, right? If I get a shell on something that I'm hacking, that means I can communicate directly to the operating system, right? Because that's what a shell is. And if I can communicate directly to the operating system, then I can do everything that you can do sitting in front of your computer with a mouse and a keyboard, right? That's kind of the simple definition, but really, there are some kind of caveats to that, and that has to do with one of these that we're going to talk about, and that's privilege escalation, right? So think about it like if I log onto your computer as well, some computers, they have like a child profile that you can put on there. And when your kid logs in as a child, maybe they can't use the internet, or maybe they can't, I don't know, delete files or something, right? So a lot of times with shells, specifically like web shells and other things, when you hack into something and you get that first shell, you might not be able to do everything that you could do with a mouse and keyboard sitting in front of a computer, because you might not be the right kind of user, right? So that's where privilege escalation comes in. A lot of times you'll get that initial shell and you'll be like a normal user that can't do a lot, but then the goal is to upgrade your privileges so that you can do whatever you want to the computer. But yeah, and then the rest of these you can read through. They're pretty straightforward. And one that you really will want to know, because we're about to answer the questions here, is access to other systems on a network, which is something that will happen if you ever, get a shell in a network. You'll probably want to try and pivot to other machines. So make sure you read through all that, and then we'll answer the questions. So question number 1, what is the command line interface that allows users to interact with an operating system? That's the shell, what we've been talking about. And then what process involves using a compromised system as a launching pad to attack other machines in the network? That's pivoting, if I can spell. Yeah. So pivoting, again, we just talked about that. And then what is a common activity attackers perform after obtaining shell access to escalate their privileges? That's another one that we talked about because it is, I would argue, one of the most important things in that. All of them are important, but one of the, wow, I can't spell to save my life. I was distracted. Yeah, anyways, back to what I was saying. It's one of the most important things that we talk about because that's like the first thing you learn is after you learn what a shell is, you learn about vulnerabilities that will give you a shell, then you learn how to escalate your privileges, and then you learn about things like data exfiltration, persistence, and pivoting, right? So those kind of come later because before you can do any of those, you got to learn how to get a shell. So yeah. Make sure you've read through all those, answered all those questions, and with that, you are done with task number 2. Now it's on to task number 3. So for this task, we're going to talk about what's called a reverse shell, right? So the way that this works is earlier we were talking about shells and how if I get a shell on your computer, I can access the operating system. So if you're thinking about that, you're probably thinking, okay, for someone to do that remotely, right? Because they're not obviously sitting in front of my computer. They have to make a connection to my computer, right? And that's called a bind shell. We'll talk about that in a minute. But first, we're going to talk about a reverse shell, which is instead of the hacker connecting to you, who, the target that it's trying to hack, the hacker tricks their victim into connecting back to them. Now, why would they want to do this? The reason why they're talking about reverse shells first here is because they're the most common. You'll see them the most often, and you'll probably use more of them in your life than you will bind shells. And that's because when you get your victim to make a connection to you, that looks a lot less sketchy on their computer, right? Their firewall sees, hey, the person sitting in front of this computer is just trying to make a connection to something, which is normal. We do that all the time when we use computers. You connect to the internet, you connect to your email, you do all sorts of stuff, right? But all of those are outgoing, right? And so a firewall sees that and says, oh, that's okay, you can do that. But if a firewall saw us trying to connect directly to our victim computer, a good firewall would have some rules put in place to hopefully stop that kind of connection. But if we can trick our victim into connecting back to us, that just makes our life a whole lot easier and it's much harder to detect. So how does that work? Well, to get someone to connect back to us, first, we have to set up a netcat listener, right? And this is basically, we have to set up our computer so that we're waiting for that connection back. And a common way to do that you'll see a lot is using netcat. Now, netcat is a super awesome tool that basically allows communication between two computers, and you can use it on the command line. And that sounds really simple, but netcat can actually do a ton of stuff and it's very flexible. So you will probably have a lot of exposure to it, especially if you go into cybersecurity. But yeah, the way that it works is right here, NC, and that's going to call the netcat right? So that means you're using netcat. And then this -LVNP. They kind of explain it down here, but what that means is the -L tells netcat to listen. So we're not sending out a connection, we're just opening a connection on our side and waiting for someone to talk to us. Then the V is going to enable verbose mode. And that's a fancy word for saying, hey, the netcat is going to give us a lot of details as to what's going on. Then after that, you have N, which is going to prevent DNS resolution. So if you don't know what that is, don't worry too much about it. You should give it a quick Google. You should know it, but it won't affect you too much for this room. But basically, DNS converts from IP addresses to domain names. So when we put N, that -LVNP, we're telling netcat, don't use domain names, just use IP addresses. Okay, so we only want to use IP addresses. And then the P, that's going to say what port we're waiting on, right? So we're going to open up a connection on port 443 in this example, because that's where we're going to sit and wait for someone else to talk to us. Now, why port 443? The reason why it's on port 443 is because it's a well-known port that other people commonly connect to, right? So when I go out to the internet, if you're on your internet browser, chances are you're getting out there and you're connecting over port 443. So because of that, again, it just is another level of like disguise, and it makes it hard for people to detect what we're doing. So ports like 5380, 8080, 443, 139, or 445, that blends in with normal traffic. So that's why we're going to wait on port 443, right? Now, once we have our listener all set up, what we need to do is we need to actually get the victim to connect to our listener. And that's a little tricky. And this is where, if you're trying to really understand this room, it might kind of get complicated, a little bit intimidating, but it's really not that bad. So what we're going to do is we're going to look at this command. So this is a command that if I get the victim to run this command, they will automatically, not only will they connect to my open port on 443, but they will give me a shell, and I can start sending commands to their computer. And we're going to walk through how this works. But before we do that, you have to understand a couple of things. The first thing you need to know about are called pipe files, right? And that's what this MKFIFO creates a named pipe, or FIFO, first in, first out. Name pipes, or I just call them pipe files, honestly, because they're like, it's in Linux, so everything's like a file, and they're treated a lot like pipes. So anyways, all of this to say, there's this special type of file. You can call it a name pipe. You can call it a FIFO, first in, first out. You can call it a pipe file, whatever you want. I don't really care. But we need to know how they work. And the way that they work is pretty simple. So it's a file that allows two processes to communicate. So one process can write to it, and then a different process could read from it. So just as an example of how that works, let's say you have process 1, and it's going to write to the pipe file, and it's going to write the words hello in text. So when it does that, it sends hello to the pipe file. Now it's inside the pipe file, and it's sitting there waiting, and it's held in memory, right? Then let's say a different process, process number 2, accesses the pipe file to read from it. Well, what is process 2 going to get? It's going to get the text hello. Then after that's been read, the pipe file is now empty. So the data that was held in it now is gone, right? So it's literally like a pipe. One file or one process wrote to it and sent the words hello. Another process read the word hello, and then the word disappeared, no longer in the pipe. So this is how it works, and you can have two processes communicate back and forth by taking turns reading and writing to this pipe file. Okay, so we got to know what that is. Then the last thing that we need to know to really break down this long looking command is we need to understand standard input, standard error, and standard output. And we also need to understand two basic redirect operators that we'll kind of talk about. But first, we'll focus on standard input, standard output, standard error. So, pretty simple. Standard input is just where a program receives its input from, right? So when you're using your computer normally, your standard input is going to be from your mouse and your keyboard, right? Because that's how the computer receives information from you. So that's normally what like your whole computer's standard input is your mouse and your keyboard. Now, what's your computer's standard output? That would be your display, right? Or your screen. When you open up a document and you type in from your keyboard into your computer, so that's again your standard input coming in from your keyboard, where does that text show up? It shows up on the screen, on your Word document, right? So your screen is generally your kind of standard output. And then standard error is where do errors go, right? So if I'm running a program and it runs into an issue, you'll get those little pop-ups on your computer that give you an error code. So again, where is your standard error going? It's also going to your screen or, what was the other word I just used? Your monitor. There you go, right? So that's generally speaking what standard input, standard output, and standard error are. Now, when we get into more complex stuff, don't think of it so much. That's a good example to keep in mind, but that's not like a hard, fast rule. When we're talking about standard input, that just means where is the input coming from? Standard output, where is the output from our process going? And then standard error is where do the errors go? Okay? And so when we're talking about a terminal or a shell, right? Inside a terminal, your standard input is going to be your keyboard because you can't use your mouse in a terminal, right? Generally speaking. So it's going to be your keyboard is your standard input for your terminal. And then your standard output and standard error are also going to be the terminal because the text will come back to you inside the terminal. So the terminal is your standard output, your standard error, and your standard input would be your keyboard. And so now we're going to kind of talk about that, but within reference to shells. Now, the last thing that we need to know to really understand this command are going to be, what are they called? I'm forgetting the name. Redirect operators. That's what it is. I had to pull it up over here in another screen. I couldn't remember what it was called. So redirect operators, we have one right here, right? And so this one is going to be our redirect operator for standard output, right? And if you think about the symbol, it kind of makes sense because it's pointed to the right, and we read from left to right in the United States. So when you're doing that, it's kind of you're reading from left to right. So your standard output is going to be pointed to the right. It's the end result, right? And then the opposite of this, where it's pointed to the left, that's going to be your standard input, right? So those are kind of the defaults. And then something else that you need to know is these numbers, they actually represent something. So when you have a 0 here, which a lot of times is just assumed, it's the default, but 0 represents your standard input, 1 represents your standard output, and then 2 represents your standard error. So just as a quick example, so this one, what we're doing is we're saying take 2, which is our standard error, right? And redirect that to the same place where our standard output is. That's what the and 1 does right there. It says we want to take 2, so all of our errors, and we want to put it in the same place as our standard output. So the same place as 1, and we're going to redirect it there. Okay, so hopefully that helps. You can always Google it more if you feel like you need more explanation. Now we're going to go through step by step how this command actually works. Okay, and it's It's a lot, but you can do it. So first, remove. So RM, that stands for remove. And then -F, that's going to say force. So what that means is the terminal's not going to ask you questions. It's not going to say, hey, are you sure? It doesn't question you. If you put remove -F, whatever you put after that gets deleted, right? And so they're going to delete an F file. That's the name of the file. And it's located in the temp directory or the temporary directory. So that's what this first command does. Then this is just in bash. It's a command separator. So this is one command. Then it'll immediately run this next command. And what this is going to do is this make FIFO. That's going to create a pipe file, right? And it's going to name that file F, and it's going to put it in the temporary directory. So you can see we wanted to delete it first to make sure because let's say there was accidentally, let's say we were hacking someone and they had a file inside their temp directory titled F, then the command would get all messed up. So to be safe, we delete that file first, and then we create it, and we create the pipe file. Now what we're going to do is we're going to cat, which is going to read everything from the pipe file, and we're going to pipe it, right? And pipe just sends whatever output I get from this command. So when I run this, whatever I would normally get to the terminal, instead of seeing that normal output, it just gets carried over and put right into here as input. So I'm going to cat whatever's in the pipe file. And then I'm going to pipe it, or in the F file, I should say. I'm saying pipe too much. That might sound confusing. But yeah, I'm catting the pipe file named F, and then I'm going to pipe that to, or send it over to this command. Now this command, sh, is going to invoke a shell. So it's just going to pull up a shell for us. The -I makes it an interactive shell that we can actually like work with. And then the what's that symbol called? I can't remember. I need to remember it later. But anyways, actually, you know what? This is going to drive me nuts. I just need to Google it right now. I need a good name for it because I'll reference it a lot. Oh, are you kidding me? That's lame. It just says the greater than sign. I thought it would have a cooler name than that. Well, you learn something new every day. Okay. So this sign, I'm going to call it the redirect operator because that's better represents what it's trying to do. So the 2 is your standard error, and then it wants to redirect your standard error to wherever the standard output is. So in this case, it's basically just combining it and saying, hey, we're going to redirect both the standard error and the standard output to the same place, which as of right now at this point is, would be like to your terminal, right? It'd be just kind of normal like that. So all this does, you can almost think of this as like it's combining standard error and standard output into one location. So yeah, that's what that does. And so now we're going to take this whole thing. So now we have a shell, and what we sent to that shell was the content of our pipe file. And now we're going to take that shell, whatever output it gives, and we're going to send that to the attacker. That's what this NC attacker IP attacker port, that's how you can make a connection in Netcat. So in our case, we would put since we're the attacker, we would put our IP address, and then we would put our port that we used earlier, 443, right? So now it's going to go from the pipe file to a shell on their computer. Then it's going to come back to us, right? And we're going to see everything, right? Because they're redirecting the standard output and the standard error to us. So we get to see everything. And then once we see it, whatever we put in here is going to get redirected again back to the temp file, or not the temp file, the pipe file in the temp directory titled F. And if you remember all the way back here, what are we going to put into the shell? We're going to put that same thing. So what this does is it creates a loop. where we start a listener, the target opens a reverse shell, the pipe file is created, the shell starts, and then it waits for input from the pipe file. Then once the shell gets input from the pipe file, it sends it to us, the attacker. We get to see everything. And then we can send any command that we want back to the pipe file, and it's automatically going to get sent back to the shell. It creates this really nice loop for us. Now, if any of you are really clever, you're looking at this, maybe you've paused the video, maybe you're studying, and you've thought to yourself, wait a minute, how can this possibly work? Because my pipe file is empty. So if I cat an empty file, it's just going to wait, right? And then I need to send that to my shell, but my shell's going to wait for the temporary file. And then nothing's going to get back to the attacker. And if that connection is never made to me, how in the world am I going to send my command back to the pipe, right? So you might be wondering, if the pipe's empty, how exactly does this work? And I thought this, and then I did some Googling and I realized, wait a minute, these all run in parallel, which means these commands, they all kind of start and will run. So even if cat is waiting for us to put something in the temporary F file, shell can, will still start, they'll still make the connection, and then we can be the first person to put something in that F file and then really start the cycle. You know what I mean? So that's why it still works, even though if you think about it too hard, you might get a little confused, but don't worry about it too much. Because this will work. And that's because these commands run in parallel, right? So then after that, the attacker, again, receives the shell. We kind of already talked about this, and this is what it would look like, right? So we set up that listener, and then it says, we're listening on port 443. Then we get our victim to execute this command on their computer, and then we would get this. Connected to, from, wherever, run command, and then it's going to automatically just give us that shell, right? So make sure you've read through all that, and then we'll answer some questions. So question 1, what type of shell allows an attacker to execute commands remotely after the target connects back? Hopefully you get this one. This is what we've been talking about. That will be a reverse shell. And then what tool is commonly used to set up a listener for a reverse shell? That will be in Netcat. And there you go. With that, you have finished task number 3, reverse shells. Now it's on to task number 4, where we'll talk about the bind shell. So here, pretty straightforward. I don't have to go over a whole lot. This won't be nearly as intensive because, again, a bind shell is when instead of us tricking them into connecting back to us, we just connect directly to our victim. We make them set up the listener, and then we connect to them, right? So why would we want to do this? A big reason why we'd want to do this is because in some unique situations, maybe the machine we're trying to hack can't actually make any outbound connections. That's really honestly one of the only scenarios where we would want to use this, because generally speaking, the reverse shell is going to be better. But occasionally you may run into an instance where a reverse shell is getting blocked for whatever reason. Again, maybe they can't make outbound connections. And so you may have to use a bind shell in order to get onto your target. So this is almost the exact same thing, their example here, except instead of SH, they use bash, but they still make it interactive. They still redirect the output and standard error to the same place. And then here, notice their netcat. This is the big difference. Their netcat command is different, right? Instead, they start a netcat listener because -L, we talked about that. So they're going to listen for any connection. That's what the 000 does on port 8080, right? So they're waiting for us on port 8080. And then what we do, which is down here, is instead normally we would do, wait, where did it go? Oh yeah, no, it's right here. So normally we would set up the listener for a reverse shell, right? That's what we did last time. But this time instead we just do this. We start the listener and we connect directly to port 8080. So before, when we did the reverse shell, we started our listener first, then we got them to execute the command to connect us. In the bind shell, what we'll do is we will actually get them to execute the listener, and then we'll connect directly to it. And again, here, N and V, same thing. N is going to disable DNS, so only use IP addresses. V is going to give us extra details. And then our target IP address will be the IP address of our victim, and we want to connect on port 8080. So once we execute all that, in the loop here is exactly the same. So you can go through step by step, just like we did with the first one, and it'll work. And so this is kind of the output that we would get. It would say this, it's been opened. We're on port 8080 with, and there's our shell right there. And we can type in commands. So read through all that, and then we'll answer these questions here. So what type of shell opens a specific port on a target for incoming connections from the attacker? Bind shell. Right? Why is it taking so long? Well, we'll answer the second one, I guess, while it's loading. Listening below, which port number requires root access or privilege permission? Okay. So this one is 1024. Why? Because if you read all of this, it says it. Where does it say it? An unknown error has occurred. Oh, okay. I guess it just didn't want to work for a second. It does say this somewhere. I kind of forgot where it said that. Oops. Yeah, we need to note that ports below 1024 will require netcat to be executed with elevated privileges. So that's ports below 1024. So that's why we're using 8080 to avoid that problem, because it's higher, right? And why do they do ports below 1024? Because again, those are well-established ports that often blend in with traffic, most of them. So yeah, that's a good thing to keep in mind. Good little note that I kind of missed there, but it's in the questions. So make sure you've read everything, answer those questions, and then with that, you have finished task number 4. Now it's on to task number 5. So here we've already talked a bit about the reverse shell and bind shell, and really a shell is made up of 2 components. And I've kind of already alluded to this, and I've said it a few times, but there's listeners, and I'm actually going to close this, and there's payloads, right? You have the listener, and then you have the payload that actually will connect back to the listener. So these next 2 tasks, that's what we're going to talk about. So in this one, a common listener is netcat, right? But there are other listeners, and some of them are pretty cool, but I don't know why I'm saying but. Yeah, there's listeners that are pretty cool. However, a lot of times with like capture the flags and stuff, you'll see just regular netcat, but we can do lots of other ones, like our LRAP, which basically what this does is it adds some additional features. Like you can use arrow keys, you have a command history, you can line edit. So there's certain things that don't come built into netcat that are kind of a pain. And so our LRAP, you can actually use that with netcat, and then netcat has some of those additional features, right? You also have ncat, which is, if you've used an nmap, it's by the same people that made nmap, and it has additional improvements as well. Some of those features we talked about for our LRAP, but it also has encryption, right? So you can actually encrypt stuff, which is very useful if you're trying to do data exfiltration, stuff like that. You'll want that to be encrypted. So, and then they actually give us an example here. So, and same thing, I forgot with the LWRAP to just, you pretty much do the netcat command. You just put rlwrap before it. So that's how you add that to your netcat. And then ncat, to use that, you use ncat, very similar syntax. But here they do the -SSL. So that flag will actually encrypt the listener. So that's pretty cool. Then another one that you have is SOCAT. So SOCAT, that has to do, it's called that because of sockets, right? So to understand this, you kind of need to know more about connections. So when I talk about there's a listener and then there's a payload and they make a connection, right? Really, we're kind of talking about sockets, okay? And a socket is an endpoint used for sending and receiving data over a network. So a socket's like an open door that has an IP address and a port. And if you have two sockets, then that's how you actually get the connection. So a lot of times people don't always use the terminology correctly. I know I definitely don't. And I'll just talk about listeners or payloads and connections, right? But sometimes what I'm really referring to is I'm referring to a socket, which you can think of as just as like half of a connection. You need two sockets in order for them to actually connect to each other. So that's just something you should probably know. And then SOCAT, what this is cool about is it helps create socket connections. And because instead of referring to kind of the whole connection, it's more socket, which I would argue is like one layer lower, like one layer more in depth. So you can actually do a lot of really cool, customization and like advanced networking. And so like if you're a red teamer doing some real intense, highly monitored networking stuff and trying to do like a data exfiltration or get a shell, this is a tool that's kind of a level above these other ones that we've talked about as far as creating a listener. And in this case, this more accurately says we're creating a socket, right? We're creating an open socket that's waiting for a connection. And you can do a bunch of different customization and flags with this, and it's really cool. Here they do just SOCAT DD, which that's just verbose output. So two of them will be extra verbose, which means lots of details. And then, yeah, you got this TCP listen 443 STD out. And so this is kind of what the syntax looks like. We're not going to go over all of it because for now, you got to master netcat. And then I would argue from there, go to ncat, and then you'll be ready for SOCAT and really digging into the sockets and, figuring out how connections really, really work and being able to customize them. So these are just a few tools, few different types of listeners that we can use for our shells. And as you get more advanced, you'll find newer and better tools like SOCAT. So make sure you read through all that, learn a little bit about each one, and then we'll go through and we will answer some of these questions. So this first one, which flexible networking tool allows you to create a socket connection between two data sources? That's going to be SOCAT. Then which command line utility provides read line style editing and command history for programs that lack it, enhancing interaction with the shell listener? So read line style editing, that line style editing we talked about, that'll be rlwrap, which we can run with netcat. And then what is the improved version of netcat? That's just ncat. And that gets really confusing. I kind of understand why they named it that way because they already have nmap, ncat, but ncat is different than netcat, and ncat has some better features. So once you've answered all those, read through everything, you can mark complete. And with that, you're done with task 5. Now it's on to task number 6, shell payloads. Okay, so this task, oh boy. This task is quite a bit of stuff. and there's lots of commands. So yeah, I mean, yeah, that's just it seems like a lot to go through, but it really won't be too bad. So we'll get started. Please don't get overwhelmed. After I explain the first one for each section, they'll start going a lot quicker because I just want to make sure. Again, you could go through this and you could just read it, all of it and say, oh, bash. So there's bash payloads. And then, oh, there's PHP payloads and there's Python payloads. But if you really want to get good at cybersecurity, you need to learn how to like actually read these and understand what's going on, because this is the kind of stuff that you're going to look for. If you're looking at a web server and you see a PHP script with like shell underscore exec, you need to kind of know what that is. So we're going to go over it. So first, again, we're talking about payloads here. So we talked about our different listeners that open up and receive the connection. Now these are our payloads. And I think for all these, we're doing reverse shell payloads. So we're getting the victim to connect back to our listener, because again, those are the most common ones because they honestly work the best. Unless there's some reason you can't use one, they're better. So this first one, bash reverse shell, pretty straightforward. Bash -i, that's going to start an interactive reverse shell. Then you have this redirect. Is that what we decided to call it? Yeah. A redirect to the @ symbol. And what this is going to do is in bash, when you have a redirect and then that @ because the redirect is facing to the right, that's you're talking about your output. But this it's assumed that you're referring to both standard output and standard error, right? And that's kind of an assumption. That's something that you just have to Google or know. So there's no numbers here because bash knows if I'm redirecting, with that redirect and the symbol and, that means I want both of my outputs. So my standard output and standard error, which generally go to the same place, I want them to be redirected together somewhere else. And where are we redirecting them? We're redirecting them to this connection. So this is the attacker's IP, and this is the port that we're using. So it is important to note that this is like a bash feature that, well, it's not exclusively a bash feature, but in different scripting languages, bash being one of them, you can treat a connection kind of like a file, right? Because if you look at this /dev/TCP attacker IP -444, this looks like a file, but it's not. Because we have that dev-TCP, and because of the format we're using, bash will recognize this as a connection, and it will connect to whatever IP address we put here and whatever port we put here. Okay, so it looks like a file, but in bash, because of the way it's formatted with all of this, it knows, hey, this is actually a connection. So now we're sending our standard output and our standard error from this bash shell to the attacker IP address. And then the attacker is going to take 0, which would be our standard input, and it's going to redirect that to our standard output, right? So the way that this works is the shell is made, all output. So both the outputs are going to be directed towards the attacker, and it's going to be sent to that connection. Then the attacker can send back a command, and then all of that input is now coming from the connection. So all of that's now from the connection. So hopefully you can see how this makes a nice little loop, right? And so that's a very simple, very straightforward bash shell. Okay. So now on to the next one. This is a read line reverse bash shell. That's what they call it. But basically, there's a few more things we got to go over here. Some things are the same, some things are different. So one thing that's the same is we can see this dev TCP. So that's a connection, right? So what we're doing here is we're using exec5, Now exec can open, close, or duplicate file descriptors. Okay. And a file descriptor, honestly, for now, it can get a little bit complex if you get into the weeds, but literally it's just going to describe, it's a number that references something. And in this case, because we have this exec 5, that creates our file descriptor 5. And then these two symbols, again, these are our redirects. The one pointing to the right is our standard output. The one pointing to the left is our standard input. So because we have both of them next to the 5, that means that we can both read and write to our file descriptor number 5, which is now going to represent from here on out, it represents our connection, because that's the next thing that comes up. So this whole thing, what we're doing here is we're basically saying this whole command, we are creating a connection and we're calling it number 5. And you can write to it using the number 5, or you can read from it using the number 5. Doesn't matter. If you say 5 as a file descriptor, you're referencing this actual connection that we've made. So that's what this command does. Then what it's going to do is it's going to cat 5, right? So it's going to read everything from file descriptor number 5, which is what we just talked about. Then you have that. So whatever it gets from file descriptor number 5, so whatever comes in from this connection is going to then, because again, input here, remember this. So this is going to be our standard input. So it's going to cat everything. And from this connection, okay, I hope this makes sense. And it's going to read everything from this whole connection. Then we have our pipe. And so that means whatever result we have here, so whatever comes in from the connection, it will get displayed and then it will get sent to this script. And now this script is while, which is going to start a loop that's going to run indefinitely, really, and it's going to read line. So what does this do? Read is going to read a line of text from a standard input, and then line is going to be the variable that stores each line from actually being read. Okay, so the way that this works is we're going to read a single line from our input, which in this case is everything from the connection. So if I, the attacker, type in ls, then we're going to read ls, and it's going to get stored in the variable called line. Then I'm going to do line. So I'm going to actually execute that command. And then I'm going to redirect both my standard error from that and both of my standard output to the file descriptor number 5. So that's what I'm doing here. So my standard error is going to go back to my connection, and my standard output is going to go back to my connection. And then I, as the attacker, can send another command, and it's going to get read from that connection back into the loop, and this will loop over and over again. So again, it's pretty tricky. You kind of have to pay attention to the file descriptors, file descriptors, and you have to pay attention to these redirect operators, okay, and what they represent. And we already talked about how 2 is going to be our standard error, and if there's nothing there, this is our standard output because of the direction of our redirect. It's pointing to the right. So that means that's where it's going. Okay, so hopefully that made some sense. If you need help, plug it into ChatGPT. Then we have another bash file descriptor, reverse shell, but this one uses 196 instead of the number 5. So here they're going to take 0, which is our standard input, and they're going to say that's now the standard input of 196. So to be honest, yeah, nothing crazy here. They're basically just creating, they're setting that up beforehand instead of doing it later, I guess. And I actually don't even know if this means much, because what they do after is they create the connection, and they give it the file descriptor 196. Then they create a shell, and they're going to send the standard input of that. So, and output and error from the shell, right? So that's pretty straightforward. It's the difference here is we're using a new descriptor. It's doing it in a slightly different order, but we still create the connection, give it a number, we create the shell, and then we direct our standard input to that connection and our standard output to that connection and our standard error to that connection. So I actually, honestly, I don't even know why they have this here. Maybe it's a syntax thing, you know? Someone should leave a comment and tell me if they actually need that, because I don't think they do. I think you honestly could have just done this. Now, there might be some reason why that's there, but I don't think there is one because, again, they make the file descriptor and then they pipe all of the shell stuff back into the connection. So there's that. And then here we have another one, very similar, very straightforward. Bash-i creates the 5 file descriptor. And then that's going to be, you know, you can write to or from this connection. And then they're going to take the standard output, the standard input, standard output, and standard error. And they're pointing all of them back to this connection. So that's how that works. Okay, so that was Bash. Now we have PHP. So PHP is an important one because this is a common language for web shells, which we will talk about later, but it's good to know. So here, what's going on in this PHP payload, which is a totally different scripting language, so totally different rules here, really. So we have PHP-R, and all that's going to do is that is just going to run. It says, hey, whatever is in the parentheses here or the quotes, you're going to run that like it's PHP code. That's what that means, instead of PHP like looking at a file. So then in the same line, we're going to put sock, which stands for socket, and that's going to equal, you know, fsock open attacker IP 443. And then this is also a command separator in PHP. So this is the first thing that gets ran, or I guess not a command separator, but a statement separator. And then it's going to execute a shell, and it's going to pipe everything. So standard input, standard output, standard error, and it's going to send it back to this connection right here. And so you can read about that right here. It's creating it on port 443, and it used this exec function, right? And so that's the function that it's using to actually execute this. And we kind of talked about this. So what does exec do? Exec is going to actually execute commands on the server. And it's the same thing with shell exec. It's the same thing with system. And it's the same thing with pass-through. And it's the same thing with popen, right? And other than that, all of these commands are literally the exact same pretty much, right? So what they're trying to point out here in PHP is, one, it's pretty straightforward to create a socket, an open socket to a specific area. In this case, these are all creating open sockets for the victim to come back and connect to us. But what's different here is this part. In these functions are all slightly different, but I'm not really going to go into why, because that's kind of beyond the scope of this room. A lot of it has to do with like syntax and formatting and what the output is going to look like. But what they all do is they execute commands on the actual operating system, right? So it's important to know what these are. You don't have to know them perfectly. You don't have to know exactly how they work. But if you are on a web server and you see any of these functions, you got to be aware of what's going on and what's happening, because that's how you execute commands, on the operating system. So yeah, you can read through all those examples. These ones are, I mean, the bash ones were all kind of different. These ones are all the same, literally, except for one thing. So that's really nice. So you can cruise through those pretty quick. Make sure you read through them. Then the last thing, we have Python, which is very commonly used. And they give us reverse shell payloads here. So, and they kind of give them different titles, exporting by environmental variables. That'll kind of help you understand what's going on. But here we're going to export our host's attacker IP, and then we're going to export our port 433. So these are bash commands. And what we're doing is we're setting the variable for exporting. So what that means is any process started after these commands is going to inherit these variables. And in this case, we start a Python interpreter. Now here it just says pi-c. In the real command, it would look like this. It would look like Python-C. I guess they just got lazy and didn't want to type that in. I don't know why. So that's why that's there. It would really look like this in real life. But basically, we're going to export the attacker IP and their port number. So now from here on out, any process coming in after it is going to recognize these variables. So then it's to the Python, because everything before that was bash. Now we've run Python with this Python-C that should be right here. And now we're going to import some stuff. So when it says import in Python, we're just importing standard libraries. And we import system, socket, OS, PTY. These are just things that we're importing. And then this as well is going to be like our line separator or our statement separator when we're doing one-line stuff with Python. So then the next part is we're going to take the variable s and we're going to set it to socket.socket. So we're creating a socket and we're naming it variable s. So now whenever we refer to s, we're referring to our socket. Then we're going to do s.connect. So now we're going to actually, connect to something. And what we're going to do here is we're going to do the os.getEnv. And what we're doing there is we're getting the environment variable. What environment variable are we getting from the operating system? We're going to get our hosts. Then we're going to do the exact same thing with our port. And then we're just turning it into an integer. Okay. And that's a syntax thing for Python. So now we have our socket and we have connected it to the actual attacker. And we did that by getting environment variables that we had exported all the way over here, right? And now what we're going to do is we're going to do this os.dup2. And so what does that do? This os.dup2, that's going to point a standard file descriptor to a new file descriptor. So the way that this works is when we created this socket, it was automatically assigned a file descriptor. And it was done that based on how many different things we're running. So maybe if there's not a whole lot going on, because we have 0, 1, and 2, which represent standard input, standard output, standard error. So those file descriptors are already used. So maybe this got named file descriptor 3 or file descriptor 4 or file descriptor 5. I don't know. But I do know that when we created this socket, it got a file descriptor. So because of that, what this does is this is going to grab our file descriptor for our socket because S, remember, that represents our socket now. So s.file number, that's going to get our file descriptor, our old one. And then what we're doing here is we're going to set that to a new file descriptor. So we're going to set those to the same thing. And this is kind of a really roundabout way, and I'm sure there's probably a better way to explain it, but for sake of time, basically we're saying, hey, we're going to get the file descriptor for our socket and we're going to rename it to FD, and then we do a loop. So for FD in 0, 1, 2, and 2, which is all of our standard input, standard error, standard output, we are now going to redirect all of those to our connection, this FD, right? Which is the new file descriptor for S. And S is our connection, right? So that I know that was kind of a lot. And you might be thinking, I don't need to know how to code Python. I don't work with Python. I work with JavaScript, or I don't know, whatever coding language you use. And I'm telling you right now, if you get into the world of cybersecurity and you get into an advanced level, no one's going to care what scripting language you're good at, not good at. They're going to expect you to just learn and figure it out. So, the best way, in my opinion, to do that is just anytime you come across something, whether it's in TryHackMe, whether it's in your work, whatever, and you see a piece of JavaScript, a bash script, a piece of Python, or heck, if you find an HTML tag and you're like, I don't know what that is, just Google it, learn it. If you do it now, it'll save you a lot of pain in the future. And I know this seems like a lot of work just to understand basic reverse Python payload, but trust me, it's worth it. So read through all that. And then we'll jump to this second one. And this one's a little different. Basically what they do, actually, I forgot. So at the end of this one, they use pty.spawn bash. So they actually create the bash shell in that connection. So forgot about that. So that's how the loop actually works on that one. Because we created the socket, we redirected all of our input, but then I forgot to mention, oh yeah, and there's a shell, because for a reverse shell payload, you need a shell. So that's what that last part is. So here we import all of these, then we create our socket, but this time we put this in it, right? Before it was just socket and then 2 parentheses, didn't put anything in there. And the truth is we could have left this blank because these 2 values are actually the default values. But all they're really saying here is they're just saying IPv4 and TCP. That's what that means. So this is going to be an IPv4 address. This is going to be TCP connection. That's really what those mean. And then this s.connect, again, we're going to actually, now that we have the socket, we created it, we know it's going to be an IP address and a TCP connection. We actually make that connection. And then again here, OS, we're going to use this DUP2 to switch file, to redirect file descriptors basically. And so we'll take the file descriptor for our connection and direct it to 0. So now it's pointing to 0 or our standard input. And then same thing. We just repeat this step for standard input, standard output, and then again for standard error. And then we're going to import, which we could have done at the beginning. It doesn't matter, but they waited till now. Now they're going to import the pty to module to actually spawn a bash shell using the pty.spawn. So that's how that one works. So we create the socket, we create the shell, or I guess socket, I should say we create the connection because we create the socket, then we make the connection. So we create the connection, we redirect all the output to that connection and input, and then we create the shell. And then this one, again, very similar. This is just kind of like a shortened version where they're using a for loop here instead of writing it out a bunch. And then same thing. Remember how before I said they didn't actually have to put, where is it? All of this in there. They could have just left it blank. That's what they do here. They leave it blank and then make the actual connection after the fact. But it's by default, it'll know. So that's another really simple one, really short. And then there's other ways that you can make sockets, or not sockets, payloads as well. You can use telnet. This one's pretty straightforward. They're going to make a temporary directory with a random name. That's what this -u does. And they're going to save it to the TFV variable. So now that random name inside the temporary directory is going to be stored in the TF file, and then they're going to make a pipe file with that same name, and So here, I'm sorry. Did I say make a file? Because that's not what I meant. What that does is it just sets a unique file name in the temp directory and like reserves it. Nothing's really actually made here. So it's just basically saying, hey, we're going to make a file with a unique name in the temp directory, but it's not actually made. Then here's where they actually make it, and they assign it that unique name that they stored over here. The and symbol, that just means if this command runs successfully, then they will run this command. If not, then it won't work. So then they make the telnet connection, and they're going to send their standard input here or to the pipe file, because that's what that is now that they share the same name. So that's our pipe file now, because here we made the file with the same name. And here, yeah, it's kind of confusing, but they're literally just coming up with a random string. That's essentially what this does. And so our input is going to that, and then whatever is in there, that's going to get piped to a shell, SH, and then the standard output is also going to get sent back to the pipe file, TF. So again, it makes that cycle. And again, hopefully you're kind of getting the pattern here. You have to make the connection. You have to redirect all the outputs to the right place and inputs, and then you have to make sure you get a shell. And then you can do the same thing with awk. This one's a bit more complicated, and it would take forever to explain, but gosh, for the sake of being thorough and wanting you guys to learn as much as possible, even if it's useless and you only see it one other time in your career, guess what? You'll be the guy that knows, hey, you can use awk to genuinely create a reverse shell payload. And someday that might come in handy. Maybe if one of you listening becomes really important, could save a company millions of dollars. So I'll go through it, I guess. So awk, basically, this is normally not used for this kind of stuff. Awk is a scripting language normally used to deal with like, I think a lot of it's for text manipulation kind of stuff. And so this is a creative shell. But basically, we're going to run awk, which is a scripting language. Begin, that's going to kind of start everything for us. S equals, and again, this is another scripting language where this represents a connection, and it recognizes that. So now S is referring to our connection. So then it starts a loop. This 42, I don't know if that's necessary. I don't think it is. It's just basically a while loop that's going to keep on running. So there's that. Then I'll just skip to this at the end. So that while loop is going to keep on running until the attacker sends the word exit. And you'll understand why that C is there in a minute. But it'll keep running until the attacker sends the word exit. And then once the attacker sends that word, the whole thing will shut off and the loop will actually close. So anyways, but back to the beginning, because that doesn't happen until the end. So back to where we were. So we're going to start this while loop. And while we're doing that, we are going to print this. So this is what the attacker sees, right? Then we have this pipe and @ symbol. And this is an operator specific to AWK that, and I don't actually know if people call it awk. I do though, because why not? Because who wants to say AWK? Actually, AWK kind of sounds better. But anyways, so this is an operator for AWK that means to pipe to or from, basically. So we're going to pipe that to S. So we're going to take this, print it. We're going to pipe it to S, which if we remember represents our connection. So we just send this little prompt to the attacker. Then we're going to take S, again, coming from the connection. So whatever the attacker puts in, we're going to send that to get line. And what getLine is going to do, it will wait for input again because we're waiting for this S to have something. Then that'll get sent to getLine, which is going to grab whatever the attacker wrote and save it to the variable C. And C is going to represent command. That's why they chose a C. So the attacker sends something, it gets passed from the connection using this getLine ability. We're going to read it and save it to the variable C. Now, if C, which just means, hey, if C is not empty, like if it exists, what we're going to do is we're going to start another loop and we're going to getLine from C until there's nothing left, basically. So this will grab the output from the actual command. So if there is a command, it will grab the output from the actual command and it actually runs it, but we still need the output, right? So the command is run at this point, but we need all of the output from it because sometimes, let's say the attacker runs an nmap scan, he's going to have a bunch of output. So we're going to getLine over and over again until there's basically nothing left to get. And this is where programming can get confusing, guys. I empathize. This is not a redirect. This is a comparison operator. So we're saying as long as the results of this is greater than 0, so 1, then it will keep going. And that's because if this stops, if there's no more for getLine to grab, it will produce, I think, either a 0 or a -1 to let it know that, hey, yeah, there's nothing else I can read. So that's what that is. This just says, hey, run the command and then give all the output until there's nothing left. And then it'll print this $0. Now, what's that? Well, that is a default variable for AWK. So whenever you do getLine, it automatically stores it in this variable unless told otherwise, right? Because here we use getLine, but then we told it, hey, store that in variable C. Here we don't tell it where to put it. So it automatically puts it in this $0. So now we're going to print out the full output. And we're going to send that back to the connection so that the attacker can see the output of their command. Then we're going to close. We're not going to close the whole thing because that's what this does. Remember, exit is going to close the whole thing. Here, we're just going to close this like whole little chunk right here so that it can rerun with a new command, right? So that's how that one works. It loops all the way through. And then this dev null, that's just, yeah, that's there mostly, I think, for syntax, because if not, like I'm pretty sure that's there to stop AWK from reading actual data. Because again, AWK is a little funky. It's not designed for this at all, which is, it's a great example because hackers will get creative and they will use anything. But it's really designed, I think, for text manipulation. So it generally works with like provided input, but we're not really giving it any input because we're forcing it to form a connection right away. So I think that's largely why the dev null is there. So that's what that is. Then you have BusyBox, which is super easy. Netcat basically runs Netcat, gives you the port, gives you a shell. So then you're wondering, okay, well, why use BusyBox? And the reason why is because it's a tool that has all these like Unix commands and stuff. So it has all these bash commands that we have that we're using basically. But the reason why it's so cool is because BusyBox is on a lot of really small systems like embedded devices, IoT devices, that kind of stuff, right? Because if you're trying to hack an IoT device, it might not have, enough room on it for all of these other types of things that we're talking about. But a lot of times if it has BusyBox, you can still get away with some pretty cool commands. So now down to the questions. So which module is commonly used for managing shell commands and establishing reverse connections in security assessments? Ooh. Is it specific to oh wow, security assessments? I don't know. That is going to be subprocess. Yeah, subprocess. So that was, where was that? Just so you know, subprocess module. So you can learn about it. But yeah, it's a Python thing. So give it a quick Google. It's not, honestly, I don't know why that was a question, because that's not like the main thing I want you to take away from this. I just want you to understand there's a bunch of different like ways you can create shells and payloads. So PHP, that's the answer for that one. All these different functions that execute commands. That was the difference between all of them. And then which scripting by X can use a reverse shell by exporting environment variables and creating socket connections. I think, is that Python? Yes, it is. Sweet. So make sure you've read through all that. I know it's a little confusing, and I am not by any means like a phenomenal programmer. So I tried to explain these as best I could. But again, you're going to have to be able to, at least understand these a little bit if you want to go in depth with cybersecurity. So make sure you read through it, try to understand the payloads. And with that, you're done with task number 6. Now it's on to task number 7. So in this section, we're talking about web shells. Now that we've gone through regular shell payloads, we're going to talk specifically about web shells. Honestly, there's not a huge difference in like the payloads. The big difference is in kind of how you get a web shell where it needs to be, and then how it interacts with the web server to actually give you the shell. It's a little bit different than someone executing a command or a script on their computer. So we're going to talk about that. Here, some common languages that web servers support. The most common one is going to be PHP, and then ASP or ASPX. So those are the ones that you'll probably see the most. There are other ones. Here they're going to give us a PHP one. I think PHP, yeah, I would argue PHP is by far the most common in my experience. Someone could fact check me on that. I don't know how popular ASP is. But anyways, I'm pretty sure it's a PHP. So this is the example that they give us. And this is a pretty straightforward example. It's saying if is set. So this starts PHP. If, it's going to create an if statement. And if is set, and then it has this $_get. What is that? So you're going to see $_get, $_ post. What else is there? There's some other ones. And basically it's a built-in PHP array that holds key value pairs from the URL. Now, that sounds complicated, but it's really not. All that's saying is, like, in a URL, you might have something like cmd equals ls, or name equals helpful hacker, or, whatever. And this is going to get whatever the value associated with command is. And then it's system. And remember, if we remember from previously when we were looking at payloads, where is it? System, right? So this is actually going to execute commands on the OS. So then we're going to system, and then it's going to get that command and execute it, right? So that's a simple little PHP web shell right there. So you can read through all this. It talks about a couple of vulnerabilities that can allow us to get that shell on the web server. Because that's the other thing, is when you're hacking a computer, you need to find a vulnerability so you can get the payload to be executed on the computer in some way. And there's kind of a lot of options there. You could get someone to click on something. There's lots of things you could do. You get someone to type in a command by social engineering. And there's lots of options with a web server as well, but these are some of the common ones. So yeah, these are some vulnerabilities, and we will use one of them. And then once the web shell is actually deployed on the server, you can access it by navigating to the URL. So in this example, they navigate to this URL. And then once you provide the value of command in the thing, so here's what it would look like, right? So victim.com/uploads shell.php. So this is where you navigate to the actual shell, like payload. And then it has this command.whoami. And up here, command, it's going to get the value associated with that. And that's who am I. And then it's going to system who am I. And then it's going to display those results for you. Right? So that's kind of the basics of a web shell. We'll get more into it once we get into our more practical example of it. And I'm sure some of you are wondering, wait, how in the world does this work, right? Because how does the PHP actually get executed? So an important part of that is that PHP actually will execute when you request the page with the PHP script, right? And there's probably some way to turn that off. I don't know what it is off the top of my head. Someone should leave a comment educating us all about how to change that if you can. But generally, I don't even think people do that to avoid this vulnerability. I think what a lot of people do is they just sanitize the input, right? They don't have any scripts that let you place system commands. So anyways, yeah, so read through all that, and then it's going to talk about some, because this is a very simple one where you have to give it the command each time. And it's only going to give you the results of one command every time you try and navigate to the site and run the script. Now, there are much more advanced PHP web shells. And they list some of them. This Pony shell, PHP web shell allows remote command execution. It has like the interface and everything that's way nicer than just getting the command results output to you. So then you have this B374K shell, again, another shell. It has several functionalities, including file management. So that's kind of cool. C99, this is a really fancy PHP shell, has a bunch of functionality. You can just kind of see it. I mean, look at this interface. So, and there's a bunch of other web shells at this website, so check it out. And then once you've looked at all those different web shells, what vulnerability type allows attackers to upload malicious script by failing to restrict file types? That would be unrestricted file upload, I believe. I can't spell. Unrestricted. Unrestricted. Will that give me the right answer? Dude, how do you spell unrestricted? Why am I having... Oh gosh, are you kidding me? Life's a struggle. Okay, so unrestricted file upload, that was the command, and they talk a little bit about it here. And then what is a malicious script upload to a vulnerable web application to gain unauthorized access? Web shell. So that's how that works. And then, yeah, so make sure you've read through all that, have a basic idea. Like I said, we're going to get way more into how they actually work in our task number 8, our practical task. So open that. And in this task, pretty straightforward, we're just going to execute a couple of shells, basically. So we've learned the different types of shells. Make sure you've started your machine. And then we're going to navigate to this site. So I'm going to open up Firefox. And we're going to go to this website. I'm also going to want to have I'm going to leave this like this. I'm going to want a terminal open later. So we have two. We have this reverse bind shell task and the web shell task. So let's take a look here using a reverse or bind shell. Okay. So reverse or bind shell, I'm going to demonstrate a reverse shell because again, you really want to get exposure to what you're going to do the most. And most people will be using a reverse shell most of the time. So we'll just try this very first command, our very first reverse shell that we talked about. We'll try this guy. So we're going to copy that. We're going to paste it in there. Now, before we actually do anything with this, we need to open up a terminal. And what we're going to do is we're going to start netcat -lvnp. We'll do 444. So that's the port I will choose. And we will start our netcat listener, right? So now we're listening on this port for any incoming connection whatsoever. Now, if we come here, we need to change the attacker IP address to our IP address, which is 10.10.90.246. And you can see that right up there. That's our attack box IP address. And then I also need the right port. And the port here is going to be 4444. We're going to submit it. And then let's see. Did we get a connection? Connection received. SH can't access TTY. Job control turned off. Okay. So now if I ls, I have this hello.txt, index.php. And what if I do who am I? www data. Great. So now if I cd back into the main directory, which is what it told me to, if you look back at the prompt, it wants us to find the flag saved in the root directory. So there should be, there it is, flag.txt, and we will cat flag.txt. And this gives us the answer, so copy that and paste that in. Let's make sure we're right. Okay, now let's kind of reverse engineer this. Let's take a look at the hint. Place your reverse shell payload in between two of those. I did not do that, and it still worked. I wonder why that still worked. Come on now. Okay, and here we can see the actual PHP that we messed with, right? So here they have this PHP, error reporting equals 0, file, post, file. So this file variable that we're getting from the post form, from that form data in our post request that we looked at earlier, yeah, this is where our input goes. So then it does this user bin chaw sum hash, and then you have the file. And because of that, what we can do is it's going to connect that over here. So we should have had to put command separators. Oh, sorry, command separators. I don't know how well you can see that, but basically, let me just exit out of this. Okay. So what we should have had to do was put one of these before and after our command, because those are line separators or those are command separators actually, because in the PHP file, right, that they're using, they do the exec PHP function, which we talked about, and that will execute actual commands. And then they give us this SHA-256 sum that they want to perform on the name of our file. But instead, if we put this symbol, we cut off that command, and then we move straight to our command. And it can be any command we want, right? So this is an example of a command injection that we then use to get a reverse shell. So that's what this was. So now that we've done that, let's do web shell task. Okay, so now for the web shell, we're going to jump over here, open up the web shell task, and now we need to upload a file, right? So to do that, we want to do a web shell, and we have a web shell right here. So we can copy that web shell. But remember, with this web shell, when we access it, we have to actually provide the command. So it's going to be $command equals, and then whatever we want to do, right? So copy that, and then we'll jump back over here. We're going to need to open up, first we're going to start our netcast listener. And then I will open up a new tab. Here, let's make this bigger. And then on this tab, we're going to nano, and we'll call this shell.php just like they did. And then I'm going to paste in everything that we did. And I think this works as is. Should I format that? How do they have it? Let's look. No, they have it looking like that, so I'll just leave it like that. Okay, so control exit, save modified buffer. Yes, we'll save that as shell.php. Great. So now we have our listener, we have our shell. So now what we have to do is we have to upload it first before I can navigate to it. So let's upload shell.php. And then upload, it'll tell me the file has been uploaded. So then we have to navigate to it. So where is it? The most likely place is a lot of web servers have an uploads folder. And then we'll go to shell.php. But remember, now we have to do our command, which will be ? And that's going to equal, we'll do cd. Okay, so then we'll put in cat/flag.txt. Now, why do I know it's cat/flag.txt? I know that because if I come up here, it literally tells me the flag saved in the directory, in the root directory, and this was flag.txt. So I'm guessing this is 2. If not, maybe we'll try flag1.txt. We'll see. /flag.txt. And here is our flag. So we can copy that. And paste it in and submit that. Okay, so with that, we were able to do both a regular reverse shell and a web shell. We did a file upload, and we were able to upload this web shell. And then navigating to the proper URL using this command, we were able to get our flag. So, conclusion, the review of this room. At this point, you've learned about shells, reverse shells, bind shells, shell listeners, and shell payloads, which are kind of the two halves of the shell that you need to actually create a shell that works. You also have web shells, and then, of course, we actually practiced. So make sure you've read through everything and mark complete. And with that, you have finished the shells overview room from TryHackMe.